Okay, we will finish this third section of this chapter with 2 examples. Okay. The first one says use multilinearity to find the determinant of the following matrix. 1, 3, 3, 2. Okay, and just recall one of the properties of a multilinear function. The first one says f of row 1, row v plus row w, row n. So the function is linear in rows. Okay, so we are going to split the function into two. We have the f of row 1 v row n plus f of row 1 w row n. Okay, so we are going to use this property to find the determinant of 2 by 2 matrix. And okay, I will do the example and then I will make a small observation. Okay, so the determinant of this matrix 1, 3, 3, 2, according to this property, okay, we are going to split the first row into two. So this first row, okay, let me show you somewhere here. The row 1, 3 can be written as okay, can be written as 1, 0 plus 0, 3. If you see, so 1 plus 0 is equal to 1. Okay, 1 plus 0 is equal to 1, and then 3 plus 0, sorry, 0 plus 3 is equal to 3. So 1 plus 0 is equal to 1, and 0, sorry, 0 here. Okay, let me show you clearly. Let me repeat. Concept of multilinearity. So we have this first row, okay, can be split into two, can be written as v and w. So 1, 3 can be written as 1, 0 plus 0, 3. So just a quick check. 1 plus 0 is equal to 1, and then 0 plus 3 is equal to 3. So we can write this row as the sum of these two rows. Okay. So let's do the permutation expansion. So here we have the determinant of 1, 0, 3, 2. So we keep the second row unchanged. So plus 0, 3, 3, 3, 2. Okay. Then what I'm going to do is to split this this row as well. So this second row. So I'm going to I can write the determinant of this matrix as the sum of two other determinants. So the row 3, 2 can be written as 3, 0 plus 0, 2. As a quick check, we have 3 plus 0 is equal to 3, and then 0 plus 2 is equal to 2. Okay, so I'm going to split this matrix. Okay, so 1, 0, 3. So in this case, I'm going to keep the first row intact. So I'm going to write this matrix as the sum of two, as the sum of the determinant of two other matrices. So we have 1, 0, 3, 0 plus 1, 0, 0, 2. Okay, so this is expansion of this first matrix. Then now I'm going to do the expansion of the second matrix. So plus, I'm going to keep the first row unchanged and do the expansion over the second row. So you have a 3, 0 plus 0, 3, 0, 2. So, okay, this is for this second matrix. Okay. So now what we are going to do is to multiply down the diagonal. We have seen earlier. So okay, let me show. For the first one, the matrix, the determinant of the first matrix is going to be 0. Why? Because the second row is a linear combination of the first row. So the second row is 3 times the first row. And if you remember in one of the lemmas, that means the determinant of this matrix is going to be 0. Why? Because if you do Gauss's method, the second row is going to be 0. So the determinant of a matrix containing a 0 row is going to be 0. So here we have 0. The determinant here, this matrix is in echelon form, so we have to multiply down the diagonal. Okay, and for here we have to swap the rows. So here, and we have seen in the properties of determinant that swapping rows change the sign of the determinant. So we have -1. Okay, let me show here. That means we have minus determinant of 3, 0, 0, 3. So I swap these two rows. Plus here as well, the determinant is going to be 0 because the second row is the linear combination of the first row. Okay, is x times the first row. The second row is 2 over 3 times the first row. Second row is going to be 2 over 3 times the first row. So the determinant is going to be 0. Here we have 0. Sorry, we can just get rid of this 0. So we have 2 minus determinant here is 3 by 3. So we have 2 minus 9, which is equal to -7. So determinant of 1, 3, 3, 2 using multilinearity is equal to -7. We'll do one more question for this part. So find the determinant of T and T transpose if t is equal to 1, 1, 1 minus 1, 1 minus 1, 1, 3, 2. Okay, so you have seen earlier that the determinant of this matrix. Okay, just check. Determinant of t is equal to 2. And we have seen in the previous video that a theorem says that the determinant, we have seen the following theorem. The determinant of a matrix equals the determinant of its transpose. So in this question, let's see if the determinant of the transpose of t is going to be equal to t as is going to be equal to 2 as well. Okay, so t transpose is going to be 1, 1, 1 minus 1, 1 minus 1, 1, 3, 2. So now let's to find the determinant of this 3 by 3 matrix. Step 1, let's do Gauss's method. Okay, so you have 1 minus 1, 1, 1, 1, 3, 1 minus 1, 2. So let's do minus row 1 plus row 2. Give us 1 minus 1, 1. So here 0. This is going to be 2. Okay, minus row 1 plus row 2, 2. 2 as well. And here let's do minus row 1 plus row 3. 0. 0 minus row 1 plus row 3. And here 1. So we have the matrix in echelon form. Step 2, multiply down the diagonal. Okay. So we have determinant of T transpose is going to be equal to 1 multiplied by 2 multiplied by 1, which is equal to 2. Okay, so yeah, the theorem is verified. Okay, so that will be all for today. In the next video, we will start the fourth section of this chapter, which is Laplace's formula. So it's going to be another way of finding the determinant of a matrix. Actually, we can derive the Gauss's formula, the fact that we multiply down the diagonal from the Laplace, or we can say that the Laplace formula is defined from the Gauss's method. So both methods are interconnected, but Laplace formula help us to find the determinant of large matrix, the same as Gauss's method. But so most of the time we normally use Gauss's method to find determinant of a matrix, but sometimes Laplace's formula might be more suitable. Okay, Thank you and see you in the next video.